Hi, today I would like to speak about Honeywell controller and to explain to you how Honeywell controller works.
This is not a commercial advertising. This is life. This is a normal working time for a technician. Imagine sometime outside rains or outside a -5 degrees. So I have to put plastic on the wet floor and cardboards to lie down with some nylon above me to fix this one because people are freezing in the store.
Today I will explain to you how a Honeywell controller S4560D1135 works. I know some of you know how this system works, but some don't, and because I couldn't find any video tutorial, I'm going to explain this because I think we all have the right to know how a control works, and every time we try to repair either a boiler, an air handling unit, or any other heating system that requires a Honeywell controller, before you will buy a new Honeywell controller, you have to make sure that the Honeywell controller, it is faulty. Because in the past 9 years, I end up with over 25 Honeywell controller which were not faulty, and they were incorrectly tested and checked, and I think the client paid a lot of money for things which were not faulty. As you'll see here, well, I try to show you very carefully what happened now. This is the place where you have to apply live and neutral. The first thing to check, if a Honeywell controller does not initiate the flame, you have to check if you have power at this point, at number 1. Number 1 you're supposed to have. You can bring the power to this Honeywell controller via a thermostat or a logic control. Every single thing that will provide power to number 1, it is okay. You can use, like as you see here, you have to have the fuse, then you have to have the switch, and you can have the thermostat, and then you can have the power supply into this module. Now the neutral is neutral, it's a constant connection, so only the live will be subject to a thermostat or a switch and etc. If you go further, number 2, it is an alarm. So number 2, in between number 2 and neutral, you can put an alarm system. Then number 3, it is neutral. I already told you what neutral does. Now let's go to number 4. Number 4, it is a reset, which means that if the flame will fail, the system will go on fault mode and will trigger an alarm. So to have this running, you have to make a short circuit in between number 4 and the neutral. Usually you'll have a switch for that. It's a momentary push button. If you move further, you will see there's a fan sign which links to number 8. Further, you'll have number 7, number 8, and number 9. These number 7, number 8, and number 9 are allocated to a differential pressure switch. 8, it is the common, and the common, it is a normal closed circuit with number 9. When number 8 will supply power to the fan, number 8 and number 9 should be in short, should be a closed circuit. When the fan starts, number 8 will be in short with number 7, which is a normal open circuit. So when the fan will start, because this connection, it is connected to a differential pressure switch, I call it proven switch sometime, which will tell us that the fan works because we have positive or negative pressure into the fan. It's up to where the little tubes that sense the air are mounted. If they are mounted on the positive pressure of the fan, then you read the positive pressure. If you'll have it on a negative pressure of the fan, then you'll have a negative pressure. I found multiple way of wiring and multiple way of locating the little clear tubes which are attaching the pressure switch to the fan chamber. So you have to pay a lot of attention. When number 8 will initiate the fan, Number 8 and number 9 should be in short, should be closed circuit, otherwise number 8 will not initiate the fan because this switch is checking itself. This is all about, this is the little mystery where a lot of people makes mistakes. Some of the people just put some wire together between number 7 and 8 and they want to simulate a pressure switch. That's not only illegal to simulate the presence of a differential pressure switch, but the system will not work because when the fan goes off, it should the differential pressure switch, it will go back to its normal position and it will be a normal closed circuit between 8 and 9. Please don't make this mistake. Then it will continue the journey after the differential pressure switch will sense that everything is okay and the fan is running. The spark plug will be initiated, and if the spark plug is okay, then the first gas valve will be open. You can have a pilot flame to send a signal to ionization probe. It will spark, the spark plug will be initiated, and then the first valve will be open. So what will be the first valve? The first valve is number 5. Number 5 will be open, and then you will still have power to number 11, which is a commune with number 10 and number 12. Now number 10 is normal open, so the number 10, it's this commune will wait until the ionization probe will send the right signal into this. So as you'll see here, you have the ionization probe, which is number 13. So the ionization probe will send the signal, a correct signal, back into this controller, and then this controller will sense the flame is present, and then you'll open the secondary valve, and then the entire burner will run. If this system doesn't work, before you rush into spending a lot of money to buy a new one, I'm going to open this for you. When you rush to spend money, it's enough to open this box, and inside you'll find an electronic circuit. This electronic circuit is not good to mess up with because there are a lot of safety which are designed by the manufacturer, and if you interfere with the electronic parts, you can affect the safety of this burner controller. And when I'm saying you will affect the safety of this burner controller, you can, without knowing, you can make a mistake and some glitches can happen inside. So the burner might run the gas valve without a flame because you can affect the ionization probe signal reading module, and that will be a very bad idea because you can happily die. I mean unhappily die, not happily die. But what can you do if before you do anything, and I think it's right for you to do that, you can look into this fuse. You check this fuse, you pull the fuse out and you test the fuse. If the fuse it is not okay, you replace the fuse, but it's good for you to make sure that you will use the appropriate fuse. Out, yeah. So you take the fuse and then you will use a multimeter to check the fuse. A good fuse. I have 0 ohms. Forget about the other 3.4 whatever. That's the multimeter thing. So when I'm saying the story will start, if the fuse is alright and you follow the right ignition protocol and you check, your fan must run first. If you supply power here to number 1, and you'll put your multimeter between 1 and the neutral, and if you see number 8 and number 9, there will be a closed circuit, then the system will initiate. It's important for you, it is to have 8 and 9 correctly wired onto this DPS, differential pressure switch, or fan switch, or proven switch, and then when the fan will start, the positive pressure or negative pressure, it's up to how you put these clear tubes from this differential pressure switch, will activate the little switch, and then you will close the circuit between 8 and 7. But this is done only to check itself if it's healthy. So if this is healthy, and then once the fan starts, this switch will close the circuit between 7 and 8. You will listen. You have to wait for 30 seconds, and then you will have the spark plug initiated. You will hear the noise. Zzz, zzz, zzz. And if you have a pilot flame, then the valve MV1 will open and will allow the gas to go via the pilot flame, which will heat up we won't heat up, we'll send the signal to the ionization probe. Once the signal will be sent to the ionization probe, then it will open the secondary valve, which is the M2, and you have the main flame, and the boiler will work. If you do everything right and this one doesn't work, then yes, it might be an internal fault. But what you have to remember, have power supply to L, life, neutral. All right, so I suggest you will check first if the circuit 8 and 9 are in short. I mean, if you have a closed circuit between 8 and 9, and when you will apply L, then the fan will work, and then we'll close the circuit between 8 and 7, and then the ignition will start. So please do not spend a lot of money. It's 180 pounds for one of these units, and I've seen so many people being ripped off, and that upsetting me, because they spend a lot of money. And sometimes it's happened to me that some people were telling me, look, I bought 2 or 3 Honeywell controllers, and system still doesn't work. They're not very good Honeywell controller, but I think they brilliant little gas controls and gas burner controls, and I think it's a very good idea to understand how it works. This is for professional technicians, which I think it's recommended to have gas safe. So if you want to do a live test, because then you have to check the gas pressure and other features related to the gas safe regulation. But as a control engineer, I can guarantee that if you'll follow the protocol I just told you, is no way you'll spend money buying a Honeywell controller for no reason. Thank you very much. The new generation, if you want to enjoy a beer, this is the new costumation 2019. You can match the environment by wearing these glasses from Hollywood, man. Hiding behind the philosophy of a non-proven existing God. Come on, guys. Go to psychiatrist.